Okay, we'll go ahead and take a look. So we have been covering object-oriented programming, and we built a deck class, and we did a bunch of stuff. We added methods, and I want to kind of keep adding more object-oriented programming methods to this, just because, again, I believe this is something that Python does really, really well. And, we have a bunch of these double underscore methods that add a lot of kind of elegance to our solution and the way we can kind of work with them. Okay, so we have this card class, okay? The card has a Dunder initialization method, and we give it a suit and a rank, okay? And then we have a couple methods. We have a string representation of the card. We have the less than and the EQ methods, which allow us to test for equality, okay? And then with our deck class, we have an initialization, a string method to give it, and that will kind of print out all of the cards in there. And then we have a few methods to kind of work with them, work with the deck, so we can pop a card, remove a card, basically dealing a card from the deck. We can add a card, we can shuffle the cards, we can sort the cards, and we are able to sort the cards because the cards have this double under less than method implemented, which allows us to do comparisons, because you need to be able to kind of compare them if you want to sort them, right? To sort them, you need to say this comes before the other, and that's what, so if the cards didn't have this, we wouldn't be able to sort them, okay? And then we also have move cards to be able to move cards from like a deck to a hand, and the hand inherits from the deck. So we have that. The hand inherits from the deck. Basically, we have that. All right, so I can kind of initialize a blank deck. I can move 5 cards from the deck to the hand. I can print out the hand, and well, basically we have the 5 things, okay? I think we covered this in Monday's lecture, but just to kind of reiterate, when you, if you create the card like this and you create card objects, they get printed out like this, okay? It just says this is an instance of the card class object located at this location in memory. And if you check kind of your variables, in VS Code, okay, one thing is that when you, if you click this variables tab, it will kind of print out the object, and so you can kind of see the value right now, okay? Right now we have card 1, card 2. These are instances of the card class. Deck is an instance of the deck class. Lowercase hand is an instance of the hand class. And these are kind of like what gets printed out when you call print card 1, print card 2. So we can actually see it on the variables tab, but if you just kind of say, hey, what is card 1? It looks like this. When you call print card 1, it looks like that, okay? Same kind of thing right there. If you do something like, give me print out hand.cards, okay, you just get a listing of all of these card objects, okay? And so this is where the double underscore rep, okay, repper, or the representation method does. And so when you say you want to create the jack of spades, the function that we, you call class card, okay? It's kind of like calling a function to create an instance of the card class object, and the way to create the jack of spades, we say, okay, suit is 3, jack is rank 11, so we do this, okay? And so this capital C card 3, 11 would be the official representation of the object, okay? And so we have two similar methods, but string will give us what gets invoked when we call print on the object, and rep_r is kind of the internal representation of the thing, okay? So now that we have this, we'll create the jack of spades right here. And so card 3 will come out as card 3, 11, rather than the old style, which is, here's an instance of a card class object. And we get jack of spades here, okay? We can still test for equality, all right? Okay, and card 2 is a jack of spades. This card 2 gets represented this way because it was defined under the old definition of the card class object, right? So we created a new definition of the card class, and so both of these are jack of spades, okay? But card 2 is a jack of spades, card 3 is a jack of spades, so we can test if they are equal to each other, and indeed it says they are equal, okay? The deck class uses the new definition of the card class, and so we'll redefine that. We'll redefine the hand class to inherit from the deck, and so now here's the deck, okay? I can print, and I'm going to create a new hand. I'm going to move 5 cards from the deck into the hand, and so I can print out my hand. And then if I ask for the attribute hand.cards, which is a list, I get a list with the card representation objects, right? Card 3, 13, 3, 12, 3, 11, 3, 10, 3, 9, which, again, not as readable as calling print on the hand, however, much more readable than what we had back here, where it just says instance of card, right? It just says main.card at these memory locations. This is completely not helpful to us, okay? Versus this, not as readable as this, but easier, much more readable for human. Okay. If we wanted to, let's say we have this hand that we have, and we can call, hand.cards and see that there are 5 cards in our hand. Right now, the hand doesn't have a repr method, so when we ask for the hand, it just gives us, instance of hand object, okay? Again, when you pull up the variables pane in VS Code, it calls print on the hand, and when you call print on the hand, it gives you multiple lines, and it just includes the first line of text when you call print on the hand. So this is what it sees. Now, if we wanted to know like how many cards are in the deck or the hand, I can try asking like, what is the length of the hand? Okay, but if I do this, I'm going to get an error. Okay, it says the object of type hand has no length, so you can't call for the length here. All right, I could call, what are the attributes that exist inside hand, and we can call vars, variables of hand, and we see, okay, there are 2 attributes. There's hand.cards and hand.label. Hand.cards is this list, okay? And if I get hand.cards, that's a list, and I can call length on hand.cards, and I'll say there's a length, it's a length of 5, okay? So the hand does have a length in that there are 5 cards in it. And we might want to have Python interact with the hand as if it were interacting with a list, where we can say, hey, what is the length of this thing, right? Because Python, you can call len to get the length of something, and you can call it on strings, and it will tell you how many characters are in it. You can call it on tuples or lists, and it will tell you how many values are in there, okay? So what we can do is Python's object-oriented system has a double underscore length method, okay? We have double under length method, and what we want this to do is that when we call length on an hand class object, what we want it to do is we want it to return the length of that list self.cards. So that's what we will do. So inside inside the deck class, okay, because hand inherits from the deck class, we're going to redefine our deck class to include this additional method, double underscore length, okay, double underscore length, and this will be, return length of that list self.cards. Okay, now that I redefined the deck class, I have to redefine my hand class to inherit from the new definition of the deck. Okay, so we kind of have to have these changes propagate through. So I have to redefine the hand class, and so I'm going to create a new deck, and then immediately after I create a new deck, I'm going to call length on the deck, okay? And so one thing I want you to notice, right now, this deck that exists, this is based off of the old definition of deck, okay? And here I'm going to create a new instance of the deck, okay? So a new instance of the deck, now I can call length on the deck, and it says there are 52 cards in the deck. And so now if you look at the variables pane, one of the columns that exists here is the size, okay? And so now size of the deck is 52 because VS Code populates this variables pane by calling length on this object and calling print on the object. And it gives you, it says, the length is 52, so that it says the size is 52. It says, when you call print on the deck, the very first line, there's 52 lines of output, but the very first line is ace of clubs. So that's what it gets shown as the value there, okay? What we're going to do is we're going to move 5 cards. We're going to define a new hand, and we're going to move 5 cards from the deck to the hand, okay? And so now the hand has 5 cards in it, and the deck has 47 cards, okay? And then when you pull up the variables pane, it updates, okay? Because, again, VS Code uses that length attribute, not the length attribute, but it uses the function length. It calls it on this. The function length now returns these values, 47 and 5, and so on and so forth. And so we have that, okay? And so again, this is all implemented just by including the double underscore length method in our class definition, and that enables features like getting the length when you pull up the variables pane, but also calling length on these things. Okay. What if I said, hey, what are the top 5 cards in the deck? Okay. Or just what is the top card of the deck? Okay. And so, I might try to say slice it, or I might try to subset the deck using square bracket 0:5. And if I do that, I get an error. It says the deck object is not subscriptable. If I try to just say, hey, just give me the top card, okay, or the index 0 card, it also just says it's not subscriptable, all right? We get the same kind of output here, okay? Or if I wanted to kind of iterate through the deck and I say, hey, for card in deck, print the card, right? Because we might think of this, if you think of the deck as being a list of card objects, you feel like, I should be able to kind of iterate through this. But it also says it is not iterable, okay? Because right now in our class definition, we have a way to kind of create the deck, and it stores a lot of the card information in a list, but the deck itself is not actually, doesn't right now behave like a list, okay? So we have issues there. All right, here I said, what if we wanted to see the hand sorted without actually changing the hand, okay? So we do have hand.sort, okay? But remember, you can call like list.sort and sort a list, but you can also just see the sorted version. You can call sorted on a list, and it gives you a sorted version without actually modifying the thing. And here it says, this is kind of interesting. It doesn't say hand object is not sortable. It says hand object is not iterable, okay? So that gives us a little clue into how when you call sorted on something, it's kind of using the iterable features of a list. Okay, so here, before I get into the next part, let me go ahead and give you your first view quiz answer. And today your first answer is the letter C. C as in cat. C as in cat. Okay, so we can have the deck start to behave like a list or a container, okay? Like a list or a container. And there are more stuff, and so I want to kind of just link this page. This is on the official Python documentation, and this is what Python calls itself the Python data model, okay? And this is basically how it envisions how like objects and data types should be stored, okay? And so let me jump down. And so we have this thing emulating container types. Where did it go? Okay, so emulating container types. This is what we want. And so we have these different things, and it tells you what are the different double underscore methods that can exist, okay? And so you'll see I'm going to bring in double underscore get item and set item, and you have other things that you can kind of read about, all right? Iter, reserved, contains, etc. All right? You can have it emulate numeric types by, and we saw some of these things with like the time, okay? So when we implemented the time time class object, we had addition and subtraction, add and subtract, and things like that, because these are things that when you have numbers, this is how it behaves. So you have a whole bunch of these different methods that do things, right? And then some of these things we've seen with and exit and stuff. So anyway, there's all kinds of stuff when you are creating your own classes. This is the ultimate kind of reference that you should be looking at, the Python data model there, okay? And you will see every now and then you will see these notes on PEPs, and PEPs are Python enhancement proposals. Basically, the Python kind of developers community talks about how do we improve Python and what kind of features do we want implemented. And so what they do is they write these PEPs, these Python enhancement proposals. They discuss them. They say, is this something we actually want to do? And then when they come to a consensus, they say, all right, this is the thing. And then they give themselves a timeline to kind of implement. And so, Python version 3.12.6 will implement these things. 3. Et cetera, will implement other things. And so there's a whole bunch of these. They started off at PEP 0, and all right, anyway, they have a bunch of these different things. It's kind of a interesting thing. It's these open source community projects, of which Python is one. Okay. So anyway, what we are going to do is we are going to use this double underscore method get item, okay? And this tells basically when you use a square bracket to subset a list, it's basically interacting with that list by calling this get item method, okay? And so the get item always requires a key. And so we're going to tell Python what to do when we request a certain kind of position, okay? So here, basically, when we say, hey, get the 0 index card, what we're talking about is look at the attribute self.cards, okay, which is a list, and then we're going to ask it to return the value in that position, okay? And this is it. This just these 2 lines. We define the get item method, the double underscore get item method, and when Python sees this, it says, oh, okay, this is how we're going to start having it behave kind of like a container or a list. And so, and we're going to say, we're going to pull out the card object at that position. Okay, so now that I've redefined the deck, I can do that. And so here is the deck, and I've printed out the entire deck. And I can slice it, okay? I can say, hey, give me cards 0 through 8. Okay, cards 0 through 8, it will now return back a list with the first 8 cards, okay? First 8 cards there. Now, it gives us the card representation, right? If you want it printed out, you can say, hey, for items in deck 0 through 8, print the item, okay? And now it is iterable, okay? So we can kind of iterate through this for item in there, print the item. So for each card in this, it's going to print it out, ace of clubs, so on and so forth. And so we can see, so this is working, okay? So this is really cool, okay? That it's just a matter of putting in this 2-line thing, get item, and then now it has all of the behaviors of a list or a container, okay? And so, if you wanted to, the way you can slice a thing using kind of double colon iteration, so you can do 12 colon, all right, 12 colon will go through the end of the deck, okay? 12 colon, basically nothing, step size 13, so remember, when you slice, you can give it a start, a stop, start, stop, step. So we're going to do start at 12, nothing, so stop all the way at the end, step size 13. So that's going to give us every 13th card. And that will give us basically just the king of whatever, king of clubs, king of diamonds, king of hearts, king of spades. Okay, so I could say, hey, for item there, print that out, and it goes through and it iterates through that object and stuff. Now that we've redefined our deck class, if we want our hand to inherit these things, we have to redefine our hand class to inherit from the deck. And so here I can do deck, define a new deck, shuffle the deck, create a new hand, and we're going to move 5 cards from the deck to the hand. And now that I have the hand, okay, I can call sorted, okay? Sorted just uses get item, okay? So here I have sorted the hand by suit. The original order of the hand is Jack of hearts, 3 of clubs, 2 of hearts, 5 of hearts, king of spades, but you can now call sorted on the hand, okay? You can now call sorted on the hand and do this, right? You can also do tuple unpacking, right? So the hand has 5 cards in it. I can now unpack it into objects A, B, C, D, and E. Okay, this is all implemented by using the double underscore get item. Okay, yes, question.
So that software requires like those equality implementations?
Yes, for sorted to work, you need a way to compare the objects within the thing. So the card objects need to have a less than operator, needs to have the double underscore less than. Okay, otherwise sorted is not going to work because you don't have a way to rank them. So the cards have to have the less than operator, but if the cards have the less than operator and the container has a get item, in conjunction, those two things can now, you can now have sorted on this, okay? So now that again, just by implementing that 2 lines, double underscore get item, all right, I can now take advantage of all of these things. Calling sorted, I can do tuple unpacking. I can take the hand, it's got 5 cards in it. I can unpack it into 5 things here. And so A is going to be the original, what is it? 211, yeah, so that's going to be the Jack of hearts, okay? print B, it should be 3 of clubs there, and so on and so forth. The hand is still that, but we can print this out, and we have all of that. So we can, you can now unpack it. You can say, all right, give me hand subset 0, okay, and it gives you the first kind of card. All right, what if you wanted to now what if I wanted to create a new card? Ace of Hearts, and I want to put that in here. Okay, replace the Jack of Hearts. Right now, hand square 0, square bracket 0 is the Jack of Hearts, card 211. What if I want to replace that with an ace? Okay, if I do this right now, I get an error. It says hand does not support item assignment. Okay, hand does not support item assignment. So I have all of these things where I can kind of get to the items, okay, but I cannot set any of the values, okay? But if you wanted to, you could, okay? And that is implemented by using the double underscore set item method, okay? So yeah, again, depending on what you're doing, you might want this where you can kind of replace cards, or you might not want it, right? If you want it to kind of be like a read-only type of thing, okay? You don't want to be replacing cards. But here we're going to have a double underscore set item, and this allows us to kind of assign things, okay? Set item will have, in addition to self, which is always going to be the first argument, okay? It has two more arguments. The key, all right, the position that you want of the object that you're going to kind of set, and then the value that you are going to set it to, okay? So we have the key and the value. And so as far as this goes, we're just going to take that list in self.cards. The self.cards is a list, and what we're going to do is we're going to subset to the location key, and we're going to set it to whatever value we pass to it. Okay, so we're going to do self.cards key value, and that will be that. And so now we can start setting items. There is a method, random.shuffle, okay, or not a method, I guess a function, random.shuffle, and that actually uses the set item thing, okay? Right now, in our deck, our, what do you call it? Our deck class, we have this method called shuffle, all right? And we call random.shuffle self.cards, right? We call random.shuffle self.cards. But if you have set item defined inside your class definition, you no longer need this, okay? You no longer need to have a dot shuffle, okay? Because you can just do random.shuffle onto the container object, and it's going to shuffle the objects inside the container, okay? So we'll go ahead and do that, right? So I've commented out this method because it's no longer needed. So here we're going to create a new instance of the deck. All right, I can just print out the first 4 cards in the deck. Okay, the first card in the deck is the Ace of Clubs, and now I'm going to change it, okay, to the Ace of Spades. Okay, card 3,1, I'm going to set it to deck 0. So I'm going to just delete the Ace of Clubs and replace it with the Ace of Spades. And so now, if I print out the first 4 cards in the deck, it has been changed to Ace of Spades, right? And so this thing uses the set item. The double underscore set item method uses this, okay? And now that deck has this get item, set item behavior, I can now just shuffle the entire deck, okay? And so here, now that I've called random.shuffle on the deck is indeed shuffled, okay? And we have all of that. I can call sorted on the deck, and what we'll see is, I think there's going to now be 2 Ace of Spades. Yeah, we have Ace of Spades, and we don't have an Ace of Clubs anywhere in here, okay? Because I replaced one of the Ace of Clubs with an Ace of Spades. So we have that. Oops, there's a misspelling. Should say private, not Privyat. Second view quiz answer. Second view quiz answer is the letter A. A as in apple. A as in apple. Okay, so anyway, this is, in my opinion, really, really cool in that Python, you just take a couple of these double underscore methods and then it kind of opens up, it suddenly makes the object or class that you're defining like very versatile. Okay, all of these things, like Python just picks up and understands, like, okay, you want to be able to slice this thing, you want to be able to subset, you want to be able to iterate through this this object, and it's able to do all of that, okay, without having to kind of define entirely new methods and things like that. Okay, all right. There's another textbook that I highly recommend, and this is called Fluent Python. Okay, so if you're really interested in upping your Python skills and abilities, I highly recommend this book called Fluent Python, and this really kind of takes so everything I've taught you so far, like it'll take you pretty far. You can do quite a bit. Okay. However, some of your solutions might be a little bit, I don't know, clunky, all right? But there's a lot of kind of features within Python, and I would not consider myself an expert in any way, because, again, when you read this guy's codes and examples here, he's really familiar with a lot of the different features within Python to make really elegant solutions, okay? That are not just like, elegant doesn't just mean like a couple lines of code, but really kind of an elegant solution is one where you can read it, even if you don't fully understand all of the mechanics of the thing. If you can read it and understand what it's supposed to be doing, that is good. If you need a ton of comments to yourself to say, like, this is what you're doing, okay, then that's not the ideal scenario. Okay. Oh, by the way, a good habit is to write comments, okay, in your code. But the reason why you should write comments is not to explain what your code is doing, but rather why you are doing this in your code. Okay. The what should be clear from reading the code itself. Okay, somebody should be able to read your code and know what it is doing. All right, you want to keep your code simple enough that someone can read it and know what it is doing without you having to say, I am assigning the value 5 to the variable x. That is a useless comment, because someone can just read x equals 5 and know that's exactly what is happening. You don't need to explain the what. Okay, however, what is useful is why. I'm choosing to create this variable because this, right? Because we're going to be using it later for this and that. That's why you would try to include a comment here. All right. So anyway, we're going to create a class of object called vector2d, and this is just going to represent basically a vector in 2 dimensions, which is really just going to be like a coordinate, right? You can think of a vector as a coordinate in space, and it represents kind of the arrow pointing from 0 to that coordinate in space, x and y. So we got, we'll take an x, make it a float, and we'll assign it to self.x, y, assign it to self.y. And then the iterable, okay, there is this double underscore iter, and that's going to make the object iterable and unpackable, okay? And what it's going to do is it's going to return each item I, okay, for I in self, in the tuple self x, self y. So it creates this tuple self x, self y, and it does that, okay? And then when you do the representation of itself, it's going to just kind of return this. The string is going to just kind of take the self and return a tuple. Okay, make a tuple of itself. Okay, tuple of itself works because of this double under iter thing. Okay, so here I'm going to create vector 2d 3 comma 4. When we call this, we get the representation, okay, which is just take the class name, okay, and this is kind of a type of the, again, type self and double underscore name is going to be the class name, right, and then parentheses 3 comma 3.0 comma 4.0, okay. String representation is going to be the string 3.0 comma 4.0, okay. However, the way this is set up, okay, self.x is float x. I could just kind of change, right? I could change the x value from 3.0 to say dog, okay? And now my vector now instead of 3.0 has dog here, okay? And so we might not want something like that, okay? Because these attributes x and y are what we call public, meaning like you can access them and you can kind of set them and things like that, okay? So this thing of my.x, yeah. So anyway, what we can do, okay, is we can have quote private attributes, okay? And we use something called this @property decorator. So decorators in Python are like a whole other thing, you can have like an entire lecture on it. But just know for now, okay, Python decorators, you can have this thing called the @property, right? And so what we're going to do is we're going to create like hidden variables, okay? Hidden variables called double underscore x and double underscore y. Now this, by doing this double underscore x and double underscore y, it makes it, I don't want to say impossible, but it will, raise errors if you try to access these values directly, okay? And then we're gonna define these functions, x on itself and y on itself, and these will then return the values at these locations, self.double under x and self.double underscore y, okay? And so these are use the property decorator, okay? And you can read a little bit more about the property decorator there. We have the same methods as before, but we basically included these things here. So now I'm going to create a vector here, and I can call my vector. All right, and so it looks the same, and you can get the value my vector.x, okay, and it returns the value 3.0. So you can still kind of interact with this. However, if you try to set the value my vector to dog, my vector.x to dog, okay, it says you can't do that. It says property x has no setter, okay? It means you can't change it, right? And if you say, oh, okay, well, maybe they're storing it as my vector dot underscore x, okay, and you try to get that, it comes back and it says, you don't have an attribute double underscore x, right? So this thing can't get accessed directly, okay? Now, these private values in Python aren't truly private in that, like, they're not like, these are not encrypted containers with secret values, okay? They are, you use these private things to kind of just prevent users from hurting themselves, okay? But if you put all these warning stickers on it to say like, don't do this, okay? But if a user knows what they're doing, they're going to find a way around it. And if they insist on hurting themselves, you can't do that, right? You can put what is it, like childproof lids on the laundry detergent, okay, to prevent babies from eating the Tide Pods. But if somebody insists, I'm going to eat this anyway, all right, you can't stop them from doing that. So if you did still actually want to access the value, you could still kind of get it here, and you could I think set it even to dog here, okay, and then so now if I do my vector, okay, so you can do it, right? So there is still a way, but this is, you have to kind of know, like, oh, this is how you would access it in order to kind of mess around with these things, okay? Whereas kind of the trying to access it directly with _x or whatever, trying to just kind of set things the old-fashioned way isn't really going to work. Okay, I have these additional things called Pythonic features. You know what? Let's wait until Friday, and we'll I'll start introducing some of these other Pythonic features. There's kind of, again, neat little things that Python can do that kind of just make your life easier. There's like common things, like for example, enumerate is a handy little feature. You have the zip object, and enumerate will basically zip the things with a range object to kind of enumerate them and things like that. And that there's a handful of these things that Python includes. And so I thought we'll take a look at a few of these things, and so we'll take a look at that on Friday. All right, so we'll go ahead and end here for today. And how many answers did I give you? 2. Okay. All right, so I will give you your third answer. I'm going to go ahead and stop the recording.